if we want to simplify, eventually we're going to use the power rule, but to remind you, the fallback plan when it comes to exponents is to just expand. So if you forget your rule, we're going to go ahead and just expand this out. So y to the 6th power is y times y times y times y times y times y, and y to the 4th power is y times y times y times y. Then I can cancel, when I have everything turned into multiplication, I can cancel anything that's the same. So this y, for example, and this y, and then this one, and this one, this one, and this one, and then this one, and this one. Okay, and then in this case, we have a couple of y's left over in the numerator, and so we end up with y to the 2nd power. Now, when everything's crossed off, technically there's still a times 1 there, so it would be over 1. But when you divide by 1, you get the original, so I'm going to end up with y squared. Now, if you use your exponent rules, when you have like bases, then you subtract exponents. But being able to visualize this is helpful in remembering the rule, because sometimes students will ask me, well, how do I know if the variables are left over in the top or the bottom, in the numerator or denominator? Well, they're left over, the leftover is going to be whichever has more. So I will be subtracting 6 and 4. So 6 and 4, and I have this in my numerator, I end up with y squared because there were more y's in the top, so when I do the subtraction, the y squared is in the numerator. Okay, and then here's another one to kind of show how that looks side by side. So if I do x squared and I expand, I have x times x, x to the 5th, and I've expanded, I go through and I cross these out. So these two cancel these two. There's always a times 1, so there's a 1 still in that numerator. And then I have x to the 3rd power in the denominator. If you use your rule, yes, you're going to take 5 minus 2, but there are more x's in the denominator, so the leftover are going to be in the denominator. So I'll have a 1 in the numerator, and then I'll do the 5 minus 2 from here, and then I end up with 1 over x to the 3rd power. Again, the key is there were more x's in the denominator, so the leftover is in the denominator. Okay, so here's just one more here. All right, this one we don't see the exponent, but it doesn't really matter with this method. If I expand, I have my bad, go back there for a second. This one. Okay, so I have a, and then if I expand a to the 5th, and then let's cancel out anything that's the same in the numerator and denominator, so one of these a's can cross off. The leftover, there's nothing in the top, so there's a times 1. And then in the denominator, I'm left with a to the 4th, and then that one's simplified. But here, I don't see the exponent on a, so I'm just going to put a 1 there to emphasize that. And then I have my a to the 5th in the denominator. So applying this rule, I'm going to subtract my exponents, but there are more a's in the denominator. So when I subtract 5 minus 1, the leftover is in the denominator. All right, so here we go. So I have 1 still in the numerator, and then the leftover 5 minus 1, I end up with 1 over a to the 4th power. But worst case, if you get stuck, just expand and cross things off.